The journey of the machine gun is a fascinating tale of technological innovation and its profound impact on warfare. It begins in the 19th century with the invention of the Gatling gun, which marked the inception of automatic firepower. Invented by Richard Gatling in 1861, this early machine gun utilized a hand-cranked mechanism to rotate multiple barrels, allowing for a continuous stream of bullets. Although not fully automatic, it represented a significant leap forward in firearms technology, offering a level of firepower previously unseen. The Gatling gun's design was a marvel of its time, featuring 6 to 10 barrels arranged in a rotating cluster. As the crank was turned, the barrels rotated and fired in succession, achieving a high rate of fire compared to single-shot weapons. It was initially adopted during the American Civil War, where its potential was recognized but only partially realized due to its cumbersome nature and the logistical challenges of its operation. The real breakthrough in machine gun technology came with Hiram Maxim's invention of the Maxim gun in 1884. Maxim's design was revolutionary. It was the first true fully automatic machine gun. Utilizing the recoil energy generated from each shot to operate the weapon, the Maxim gun could fire continuously without manual intervention, an innovation that fundamentally changed the dynamics of armed conflict. Its water-cooled system, designed to prevent overheating during sustained fire, further enhanced its effectiveness. The adoption of the Maxim gun and its subsequent variants had a profound impact on warfare, particularly during World War I. The use of machine guns in trench warfare exemplified their strategic value. They transformed the battlefield by enabling armies to lay down a constant, devastating stream of fire, effectively reshaping tactics and contributing to the stalemate that characterized much of the conflict. The sheer volume of firepower that machine guns could deliver played a critical role in the high casualty rates and the static nature of trench warfare. World War I also saw significant advancements in machine gun technology, with the development of water-cooled and air-cooled models. The latter, such as the Lewis gun and the Hotchkiss gun, offered greater portability and versatility, adapting to the evolving needs of the battlefield. These innovations underscored the machine gun's growing importance in modern warfare. By the time World War II arrived, machine guns had become indispensable tools of war. The technological progress continued with the introduction of more advanced models like the German MG42 and the American M1919. These guns demonstrated increased reliability, higher rates of fire, and greater adaptability to various combat scenarios. The MG42, in particular, became infamous for its high rate of fire and was a staple in the German arsenal, while the M1919 was widely used by American forces for its robustness and versatility. The evolution of machine guns did not stop with World War II. The Cold War era brought further refinements, including the development of lightweight and more portable models. Innovations such as the M60 and the PKM reflected the changing nature of warfare, with an emphasis on mobility and adaptability. These advancements ensured that machine guns continued to play a vital role in conflicts around the globe, adapting to new tactical demands and technological possibilities. The story of the machine gun is one of continuous evolution, driven by the relentless pursuit of greater firepower and efficiency. From the Gatling gun's initial introduction to the sophisticated models of the modern era, machine guns have consistently shaped the course of warfare and continue to influence military strategy and technology today. Machine guns are marvels of engineering that operate based on intricate mechanical principles. Understanding their mechanics involves delving into the different systems that make automatic firing possible, as well as the various designs that have evolved over time to enhance performance and reliability. At the heart of a machine gun's operation is its ability to fire continuously without manual reloading. This is achieved through different automatic mechanisms, each with its unique method for harnessing energy to cycle the weapon. The primary mechanisms used in machine guns are recoil-operated, gas-operated, and blowback systems. The recoil-operated mechanism utilizes the energy generated by the recoil of each shot to cycle the action of the gun. When a bullet is fired, the recoil force pushes the barrel and bolt backward. This movement is harnessed to operate the loading, firing, and ejection processes. The recoil energy is used to compress a spring, which then returns the bolt to its forward position, chambering a new round. The Maxim gun, one of the first fully automatic machine guns, used this principle effectively. Recoil-operated systems are known for their reliability and are often used in heavier machine guns. Gas-operated mechanisms are based on the principle of using the gas pressure from the fired cartridge to cycle the weapon. When a round is fired, some of the propellant gas is diverted through a port in the barrel and used to push a piston or operate a rod that moves the bolt backward. This action ejects the spent cartridge, loads a new round, and returns the bolt to its forward position. Gas-operated systems are widely used due to their efficiency and adaptability. Examples include the M60 and the PKM, which utilize gas operation to achieve high rates of fire and maintain consistent performance. The blowback mechanism relies on the force generated by the recoil of the fired cartridge to cycle the action. In this system, the entire bolt and barrel assembly move backward when a round is fired, driven by the pressure of the gas. This movement extracts and ejects the spent casing, and the spring returns the bolt to its forward position to chamber a new round. Blowback systems are often used in lighter machine guns and submachine guns due to their simplicity and ease of maintenance. The Sten gun, used extensively during World War II, is an example of a blowback-operated machine gun. Machine guns also differ in their feeding mechanisms, which determine how ammunition is fed into the weapon. Common feeding systems include belt-fed, magazine-fed, and drum-fed designs. Belt-fed machine guns use an ammunition belt that links rounds together. This system allows for continuous fire without frequent reloading. The belt is fed into the gun through a feed tray, and as each round is fired, the next round is automatically advanced into the chamber. Belt-fed systems are typically used in medium and heavy machine guns, such as the M60 and the MG42. They are valued for their ability to sustain high rates of fire over extended periods. Magazine-fed machine guns use detachable magazines that hold a set number of rounds. The magazine is inserted into the gun and feeds ammunition into the chamber as rounds are fired. Magazine-fed systems are often found in lighter machine guns and automatic rifles. Examples include the Browning M1919, which uses box magazines, and the RPK, which uses curved magazines. Magazine-fed systems offer flexibility and ease of use but require more frequent reloading compared to belt-fed systems. Drum-fed machine guns utilize a cylindrical drum that stores ammunition. The drum rotates to feed rounds into the chamber, providing a larger capacity compared to traditional magazines. Drum-fed systems are less common but are used in certain automatic weapons and submachine guns. The Thompson submachine gun, known for its distinctive drum magazine, is a notable example. Cooling systems are another crucial aspect of machine gun design, as sustained firing can cause overheating. Air-cooled machine guns use the flow of air to dissipate heat generated during firing. These guns typically have cooling fins or vents to increase the surface area exposed to the air, enhancing heat dissipation. Air-cooled systems are lighter and more portable, making them suitable for infantry use. Examples include the M60 and the Bren gun. Water-cooled machine guns use a water jacket surrounding the barrel to absorb and dissipate heat. This system allows for sustained fire without overheating, as the water circulates and cools the barrel. Water-cooled systems are generally heavier and more cumbersome but are effective for prolonged engagements. The Maxim gun and the M1917 are classic examples of water-cooled machine guns. The length of the barrel and the caliber of the ammunition used in machine guns affect their performance. Longer barrels can increase accuracy and range, while shorter barrels enhance maneuverability. The caliber of the ammunition impacts the gun's firepower and recoil. Machine guns are available in various calibers, from small arms to heavy caliber rounds, depending on their intended use. Understanding the mechanics of machine guns provides insight into their evolution and operational capabilities. From recoil-operated mechanisms to advanced cooling systems, each design choice contributes to the effectiveness and versatility of these powerful weapons. Machine guns have played a pivotal role in modern combat, their development reflecting the changing nature of warfare and military tactics. This chapter explores the influence of machine guns in historical conflicts and their evolving role in contemporary combat scenarios. The First World War was a turning point for machine guns, demonstrating their devastating impact on the battlefield. Early in the war, machine guns like the Maxim and Hotchkiss were employed in static trench warfare, where their ability to deliver sustained fire made them formidable defensive tools. Machine guns were used to create murderous zones of fire that could sweep across no man's land, repelling enemy assaults and contributing to the war's high casualty rates. The static nature of trench warfare highlighted the advantages of machine guns in holding defensive positions. Their ability to provide overlapping fields of fire made it difficult for infantry to advance, resulting in protracted stalemates and massive casualties. The introduction of water-cooled models allowed for extended periods of firing, a crucial factor in the prolonged engagements of World War I. The Second World War saw significant advancements in machine gun technology and tactics. The development of lighter, more portable models transformed how machine guns were used in combat. The MG42, developed by Germany, became infamous for its high rate of fire and reliability. Its design, featuring a quick change barrel and a high cyclic rate, made it a potent weapon in both offensive and defensive roles. The MG42's effectiveness in laying down a suppressive fire was a key factor in its widespread use by German forces. In contrast, the American M1919, while slower firing than the MG42, was renowned for its durability and versatility. It was used in various roles, including as a mounted weapon on vehicles and aircraft. The M1919's adaptability showcased how machine guns were becoming integral to different combat strategies. World War II also introduced the concept of the light machine gun, LMG, exemplified by the Browning automatic rifle, BAR, and the Bren gun. These weapons were designed to be carried by infantrymen, providing mobile fire support that could keep pace with advancing troops. The Bren gun, with its distinctive curved magazine and reliable performance, became a staple of British forces, while the BAR was widely used by American troops to provide covering fire during assaults. The Cold War era brought further refinements to machine gun technology, emphasizing mobility and ease of use. The development of the M60 and PKM reflected the growing need for machine guns that could support infantry operations while being lightweight enough to be carried by individual soldiers. The M60, adopted by the US military in the early 1960s, featured a gas-operated system and was chambered for the 7.62 x 51 mm NATO cartridge. Its design included a quick change barrel and a belt-fed system, making it effective for sustained fire in various combat scenarios. The M60's versatility allowed it to be used in a variety of roles, from vehicle-mounted applications to infantry support. The PKM, developed by the Soviet Union, was another significant advancement. Its robust design and reliability made it a favored choice among Warsaw Pact forces. The PKM's use of a belt-fed system and its ability to function in harsh conditions demonstrated the emphasis on durability and operational effectiveness in Cold War-era machine guns. In recent conflicts, machine guns have continued to evolve to meet new challenges. The rise of urban warfare and asymmetric conflicts has influenced machine gun design, leading to the development of more versatile and compact models. Modern machine guns often feature advanced materials and technologies, such as polymer components and digital targeting systems, to enhance performance and adaptability. The M249 SAW, squad automatic weapon, is a contemporary example of how machine guns have adapted to modern combat needs. Chambered for the 5.56 x 45 mm NATO cartridge, the M249 offers a balance of firepower and portability. Its design emphasizes ease of use and reliability in close-quarters combat, reflecting the changing nature of warfare. In addition to advancements in design, contemporary machine guns often incorporate accessories such as optics, grenade launchers, and suppressors. These additions enhance the weapon's versatility and effectiveness, allowing soldiers to engage targets more effectively in diverse combat environments. Today, machine guns remain a critical component of military arsenals worldwide. Their role in providing suppressive fire, defending positions, and supporting offensive operations underscores their enduring importance in combat. The evolution of machine guns reflects broader trends in military technology and strategy, illustrating how these weapons have adapted to meet the demands of modern warfare. From their impact on World War I and II to their role in contemporary conflicts, machine guns have shaped the nature of armed conflict and continue to influence military tactics and technology. Their development highlights the ongoing quest for effective firepower and the ever-changing dynamics of combat. Machine guns, as powerful and influential weapons, are subject to a complex web of legal and ethical considerations. These aspects address their regulation, the impact on warfare and civilian populations, and the broader implications of their use in modern society. The legal landscape governing machine guns is shaped by international treaties, national laws, and various regulations designed to control their distribution and use. Several international agreements aim to regulate the proliferation and use of machine guns to prevent misuse and reduce the impact on civilian populations. The Geneva Conventions, for instance, establish humanitarian standards for warfare, including rules concerning the conduct of hostilities and the protection of civilians. While the Geneva Conventions do not specifically address machine guns, they set the framework for lawful combat and the minimization of civilian suffering. The Arms Trade Treaty, ATT, which came into force in 2014, represents a significant international effort to regulate the arms trade. It requires signatory states to assess the risk that arms transfers might be used to commit serious violations of international humanitarian law or human rights abuses. The ATT aims to ensure that weapons, including machine guns, are not diverted to unauthorized users or conflict zones. Different countries have varying laws and regulations regarding machine guns, reflecting their historical, cultural, and security contexts. In many nations, machine guns are classified as restricted or prohibited firearms. In the United States, for example, the National Firearms Act, NFA, of 1934 regulates the ownership of machine guns, requiring registration and imposing strict controls. The Firearm Owners Protection Act, FOPA, of 1986 further restricted civilian ownership by prohibiting the transfer of newly manufactured machine guns for civilian use. In contrast, some countries have more permissive regulations. For instance, in Switzerland, military-style firearms, including machine guns, are more accessible due to the country's tradition of armed neutrality and militia service. However, even in such cases, there are regulations in place to ensure responsible ownership and use. The use of machine guns in warfare and civilian contexts raises several ethical concerns, including their impact on military tactics, civilian safety, and the broader implications for society. Machine guns have transformed warfare by enabling sustained, high-volume fire that can decisively influence the outcome of battles. While they have provided significant tactical advantages, they have also contributed to the high casualty rates and devastating consequences of modern conflicts. The effectiveness of machine guns in laying down suppressive fire and defending positions has been both a boon and a bane, leading to protracted and bloody engagements. The ethical implications of their use in warfare are compounded by the psychological and physical toll on soldiers and civilians. The ability of machine guns to inflict mass casualties raises questions about the conduct of warfare and the principles of proportionality and distinction, which are intended to limit harm to non-combatants. Machine guns, when used inappropriately or in conflicts involving civilian areas, can have dire consequences for non-combatants. Their high rate of fire and capacity for sustained engagement pose significant risks to civilian safety, particularly in asymmetric conflicts where combatants may be intermingled with civilian populations. The use of machine guns in urban warfare, for example, can lead to widespread destruction and civilian casualties. The ethical challenge is to balance the military advantages of machine guns with the responsibility to protect civilian lives and infrastructure. International humanitarian law seeks to address these concerns by establishing rules for the conduct of hostilities and the protection of civilians. The proliferation of machine guns and their use in both military and civilian contexts have sparked ongoing debates about their regulation and impact. Critics argue that the availability of machine guns contributes to violence and instability, particularly in regions affected by armed conflict or criminal activity. They advocate for stricter controls and regulations to prevent misuse and reduce the potential for harm. Proponents of broader access to machine guns often emphasize their role in self-defense and personal security. They argue that responsible ownership and regulation can mitigate risks while preserving individual rights. This perspective highlights the need for a balanced approach that considers both security and civil liberties. The ethical and legal considerations surrounding machine guns reflect broader themes in the regulation of firearms and the conduct of warfare. As technology continues to evolve and new challenges emerge, ongoing discussions and evaluations will be essential to ensure that the use of machine guns aligns with international standards and ethical principles. In conclusion, the legal and ethical dimensions of machine guns are complex and multifaceted. They encompass international and national regulations, the impact on warfare and civilian populations, and ongoing debates about their role and control. Understanding these aspects is crucial for addressing the challenges associated with machine guns and ensuring their responsible use in both military and civilian contexts. The evolution of machine guns is marked by continuous advancements in technology, adapting to changing needs and contexts. As we look towards the future, several key trends and innovations are shaping the next generation of machine guns. These developments reflect broader shifts in military technology, tactical requirements, and ethical considerations. The use of advanced materials is a significant trend in the development of future machine guns. Innovations such as lightweight alloys, polymers, and composites are being integrated into machine gun designs to enhance performance and reduce weight. These materials offer improved durability and heat resistance while making the weapons easier to carry and maneuver. For instance, the use of polymer components in modern firearms is reducing overall weight without compromising strength, making machine guns more suitable for diverse combat environments. Smart technology is another area of rapid advancement. Future machine guns are expected to incorporate electronic systems for improved targeting, fire control, and data collection. Advanced optics and targeting systems, including laser rangefinders and thermal imaging, can provide greater accuracy and situational awareness. Additionally, machine guns may feature integrated sensors to monitor barrel temperature, ammunition levels, and firing rates, providing real-time feedback to operators and enhancing operational efficiency. Modular design is becoming increasingly prevalent in military weapons, including machine guns. The ability to customize and adapt machine guns for various roles and missions is a significant advantage. Modular systems allow for quick changes to components such as barrels, stocks, and grips, enabling operators to tailor their weapons to specific operational requirements. This adaptability can enhance the versatility of machine guns and ensure that they remain effective in a wide range of scenarios. Reducing recoil is a critical focus for future machine gun development. Recoil affects accuracy and shooter comfort, particularly during sustained fire. Innovations in recoil management, such as advanced buffer systems and muzzle brakes, are being explored to minimize the impact of recoil. These technologies aim to improve accuracy and control, making machine guns more effective in rapid and continuous fire situations. Urban warfare presents unique challenges for machine gun deployment, including close-quarters combat and the need for precision while minimizing collateral damage. Future machine guns are likely to be optimized for urban environments, incorporating features such as compact designs, enhanced accuracy, and modular attachments. Innovations like integrated suppressors and advanced optics can help address the complexities of urban combat, allowing for effective engagement while reducing noise and improving target identification. In counter-terrorism and asymmetric warfare, machine guns must adapt to diverse and unpredictable scenarios. Future developments may focus on increasing the effectiveness of machine guns in irregular combat settings. This includes enhancing their ability to engage moving targets at varying ranges and improving their reliability in challenging environments. Lightweight and portable designs, coupled with advanced targeting systems, will be crucial for addressing the dynamic nature of asymmetric conflicts. Machine guns are used not only in military operations but also in law enforcement contexts. Future trends may include innovations that cater to both military and civilian law enforcement needs. For example, machine guns designed for law enforcement might focus on features such as rapid deployment, ease of use, and versatility in non-lethal applications. Integrating advanced safety systems and controls can help ensure that machine guns are used responsibly and effectively in various operational settings. As machine guns continue to evolve, international cooperation will be essential for addressing the ethical and regulatory challenges associated with their use. Efforts to establish global standards for the development, deployment, and control of machine guns can help ensure that technological advancements are aligned with humanitarian principles and international law. Collaborative initiatives can address issues such as the proliferation of advanced weapons and their impact on civilian populations. The pursuit of innovation in machine gun technology must be balanced with a commitment to responsible use. Ethical considerations, including the potential impact on civilian safety and the conduct of warfare, will play a critical role in shaping future developments. Ensuring that new technologies are used in ways that adhere to international humanitarian standards and ethical principles will be essential for maintaining the integrity of military and law enforcement practices.